Hello everyone, welcome back. So in this video, we are going to solve a problem based on Thevenin's theorem. Okay, given here is the circuit. The circuit consists of two sources. In this example, we have one voltage source of 15 volt and a current source of 5 milliampere. Okay, let's see how to solve this. Step 1, find the Thevenin's equivalent resistance, okay, RTH. What we do in this step is, if it is a voltage source, we short circuit it, and if it is a current source, we open circuit it. So we have to short circuit the voltage source and 6 kilo ohm, and we have to open circuit 5 milliampere current source here. And also we have to disconnect the load. Here load resistance is denoted by RL, which can vary from 0 to 5 kilo ohm. Okay, we are solving for 0 to 5 kilo ohm. So let's disconnect this here and mark this point something like A and B. Okay, now I have to find the resistance seen from this port, which is RTH. So what is RTH in this case? It's nothing but R1 parallel R2, which means R1 into R2, R1 plus R2. If you substitute the corresponding values, you will get 1.5 kilo ohm. Okay, so we have completed the step 1. In step 2, we have to find VTH, Thevenin's equivalent voltage. Okay, so there may be multiple ways to solve this, but I will use superposition theorem. Okay, first I will consider only 15 volt source and I will find out what is the open circuit voltage. Okay, then I will consider 5 milliampere source and I'll say what is the open circuit voltage. Okay, so let's consider the 15 volt source alone. So when I considering 15 volt source, I will ignore the current source here, keep it open. This is port A and B, so I have to find what is the voltage here in this port. Let us denote this as VAV. Okay, so it is a simple voltage divider circuit, as you can see. So VAV is nothing but R2 R1 plus R2 into V in. Let us call this V in, okay, which is 15 volt. So substitute the values. R2 is 2 kilo ohm and 6 kilo ohm into 15 volt, and it come out as 3.75 volt. So let us call it as VAV1. Okay, VAV1 is the open circuit voltage when I consider only the voltage source. Okay, let's calculate the open circuit voltage when I consider only the current source. We had current source of 5 milliampere, and let's ignore the voltage source by short circuiting it. Now we want to see what is the voltage across this port A and B when I consider this current source alone. Let us call it as VAB2. Let it be VAB1. So you can use current division rule here. So what is total current here? 5 milliampere. And if we apply current division formula to calculate this, let it be I2. What is I2? I am using current division formula here. Okay, substitute the values. 5 milliampere, it comes around 3.75 milliampere. So this is the current through R2 resistor. So what is voltage drop? The voltage drop across R2 is nothing but the VAB2. Voltage drop across AB port as well. Okay, so VAB2 is nothing but, apply Ohm's law, I2 into R2. I2 I got 3.75 milliampere, and my R2 is 2 kilo ohm. If you calculate this, you will get something around 7.5 volt. Now I apply superposition theorem. Okay, we'll try to recall the open circuit voltage due to voltage source 1 alone. Okay, VAB1 plus VAB2. So what I got? VAB1 3.75 volt, and here we got 7.5, so it is around 11.5 volt. This VAB is nothing but the VTH we're looking for. Okay, it's pretty simple. So now we can draw the Thevenin's equivalent circuit, reconnect the load. Okay, RL, we can substitute the numerical values now. 11.5, we got RTH equal to 1.5 kilo ohm, and this is RL 0 to 5 kilo ohm. Now let's calculate current flowing through the circuit for various load resistance. Okay, the expression for I is, apply Ohm's law again, VTH RTH plus RL. Okay, so we'll substitute the various values for RL, load resistance. Okay, RL equal to 0 kilo ohm. Suppose what is current? I equal to, it comes around 7.5 milliamp. Okay, for RL equal to suppose 2 kilo ohm, R equal to 11.5, RL is 2 kilo ohm. Okay, so it comes around 3.21 milliampere. Okay, and for RL equal to 5 kilo ohm, it comes around 1.73 milliampere. The same thing can be verified in LTspice. So let us create the schematic in LTspice. Open new file. Let there be a voltage source, some resistance. So this is our given circuit. Let's connect the terminals, and load resistance can vary from 0 to 5. Let's assume this is 2 kilo ohm. We're calculating for 2 kilo ohm, suppose. So we calculated the Thevenin's equivalent as VTH 11.5 and RTH was 1.5 kilo ohm. We're calculating for 2 kilo ohm load. Okay, so what we're expecting, we expected the current flowing through 2 kilo ohm resistance is same as the current flowing through R5 resistance. Okay, according to Thevenin's theorem. So let's run the circuit for 2 minutes, and I'll probe the current across this resistor. So it is showing 3.21 milliampere. Okay, here it is in original circuit. Let's see what is happening here in Thevenin's equivalent circuit. R5 3.28. Okay, so they are pretty close to each other. So we have verified the problems that we just solved a while ago. Okay, thank you for watching.